Let's look at another line integral. In this particular problem, we have the shape of a wire modeled by this particular vector function. That is, r of t is t squared, comma t2, comma t. This is given. We don't have to actually come up with the parameterization as we did in the last problem. And also t lies in the parameter domain 1 to 4. So this represents the curve C. Okay, now the wire has a mass density rho, which is just k, a constant k times the z coordinate. Okay, and so we would think, all right, we can actually calculate the mass of the wire by integrating the mass density along the curve C here. So this is really a physics problem. Now we know how to do line integrals, especially for the scalar functions. First, what we need to do is to compute the velocity, that is r prime, and that's easily seen to be what? 2t, comma t, comma 1. And then of course we can write the speed, which we need for the definition of line integral. And so that'll easily give us 4t squared plus a 4 plus a 1 square root, of course, to give us the square root of 4t squared plus 5. Now remember, when we had the line segments, the speed was constant for obvious reasons. And so now, as I've said before, the mass of the wire will just be integrating the mass density along the curve C. So we just go ahead and replace our definition for mass density, which is kz. And now we apply the definition of line integral. We just do a composition. The only coordinate we have is z, and we replace that with t. So in this case, we just have the k times the t, and of course our speed, dt. Now, of course, this is a nice integral we can rig, add 1, divide by the new power. The chain rule says we need an 8t. We only have a t. So I'm going to put the 8 here and factor the k and then pay for the 8 with the 1/8 right here. So this now is just add 1, divide by the new power. So the new power is 3/2. Division by 3/2 is 2/3. Now notice the 2 absorbs into the 8 to give us a 4. 4 times 3 is 12. And then now we just evaluate it 4. So we'll have a 4 times 16 plus 5, and we'll evaluate it 1. And that'll just give us a 4 plus 5. Now, of course, this will just be 64 plus 5, which is a 69. So we have basically the, 3/2 power of 69. And then here we have the 3/2 power of 9. Okay, well, this one's not very nice number. Well, we can just write it as 69 times the square root of 69. And then, of course, the square root of 9 is 3, and 3 cubed is 27. So the mass of the wire, given these parameters, will be k over 12 times the quantity, 69 square root 69 minus 27. And we are done.